Water is the most precious gift of nature to mankind. All forms of life depend on water for survival. The increasing demand for water due to our growing population has resulted in great stress on all water resources. Water resources development, its utilization and management have become the symbol of economic prosperity of any nation. In India, the area irrigated by groundwater sources has increased from 6.5 million hectares during 1951 to 42 million hectares during 1997. Groundwater abstraction structures have increased tremendously. Groundwater in the irrigation sector has increased to more than 50% as of today, and its contribution towards rural drinking water supply has reached about 90%. Groundwater is the only source of water supply in areas where perennial surface water sources are absent. Groundwater abstraction structures have increased tremendously. Overexploitation of groundwater has resulted in the decline of groundwater levels, drying up of wells, and consequently, poor water supply from them. The artificial recharge of subsurface aquifers is the only solution to control the depletion of aquifers, to maintain the balance between groundwater extraction and groundwater use. Rain is the primary source of water for all types of recharge measures, but its distribution over time and space is too uneven and uncertain. Unfortunately, there is no substitute for this natural resource. Its quantity in the hydrologic cycle remains fixed. Our present and future requirement of water depends on the conservation of rainwater, and there is a need to take up urgent steps in this direction. We only remember the importance of water during a crisis and conveniently forget about it during abundance. However, now, planners, technocrats, bureaucrats and others have started orienting themselves to find the feasibility and applicability of groundwater recharge through rainwater harvesting. Rainwater harvesting is an old technique gaining popularity in a new way. It is the process of capturing and storing rainfall to prevent surface runoff, evaporation and seepage for efficient utilization. It can be conserved in surface as well as in subsurface reservoirs depending on the prevailing hydrogeological conditions. Artificial recharge of groundwater is another method used to enhance the scarce resource in addition to the natural process. Artificial recharge projects are site-specific and are normally taken up in areas where groundwater levels are declining on a regular basis, areas where availability of water is inadequate in lean months but where there is availability of surface water for recharge during the rainy season. The construction of various recharge structures such as percolation tanks, check dams, subsurface dikes, recharge wells and rooftop rainwater harvesting schemes were implemented with a view to evolve technically feasible and economically viable designs. In Karnataka, groundwater irrigation has gained importance during the last decades through dug wells, dug-cum-bore wells and bore wells where perennial rivers are absent. Kolar is one among such districts which have experienced groundwater development. Here, desilting of tanks at Erapothanahalli and Manchiganahalli and converting the same into percolation tanks, watershed treatment, construction of point recharge structures, gravity recharge experiments were taken up on an experimental basis. Infiltration test results carried out at tank beds showed an improvement in tank bed percolation after desilting. The built-up storage was observed to be 2 to 4.5 meters to the downstream side of the tanks. Basavapura and Bhuvibikanahalli micro-watersheds were taken up for the construction of traditional water harvesting structures. Check dams are major structures constructed under this program. The watershed treatment has resulted in the rise of groundwater levels up to 4 meters and has helped sustainability of yields in bore wells. The pumping capacity has increased by 4 to 6 hours in comparison with pre-project durations of 2 to 4 hours. There has been a shift to more remunerative crops such as paddy using groundwater. The watershed treatment proved that they can arrest runoff during monsoons and enhance recharge to groundwater. The construction of the point recharge structure was designed to effect direct recharge to the deeper aquifers. It is characterized by secondary porosity and involves two stages of work. Firstly, the construction of a bore well for recharge, and secondly, designing a filter bed around the recharge bore well. The surface water, either from the minor irrigation tank or from the nala, is allowed into the filter bed. The silt-free water from the filter bed will be let into the recharge bore well tapping fractured aquifer. These structures are located along stream courses or within the tank bed itself. The recharge has benefited the deeper aquifer to build up storage locally and to improve the groundwater potential. Gravity recharge well fields were constructed at Belchikanahalli and Husseinpura. Short duration intake capacity tests were also conducted. The source water for the tests was transported through a pipeline from an existing irrigation bore well located about 700 meters away from the well field. The experiments carried out indicated an intake of 3 to 4 liters per second of the aquifer, namely the weathered and fractured granite gneisses. This technique of recharging the fractured aquifer can be replicated in similar environs depending upon the availability of clear and silt-free source water. Let us now look into the conditions prevailing in urban areas. Haphazard lifestyles and rapid industrialization without proper attention to sewage and waste disposal causes pollution of groundwater. The Vrishabhavati river, which flows beside the Bangalore University, has now been turned into a sewage drain. The water requirement for the Bangalore University, therefore, is being met by groundwater pumped through bore wells. This has resulted in the dramatic lowering of the water table. There is also the threat of groundwater pollution due to the seepage of sewage water from the Vrishabhavati river. The situation will be alarming in coming years unless some remedial measures are taken immediately. Under the Central Sector Scheme, a project to artificially recharge groundwater has been executed in the Jnana Bharati campus of Bangalore University, which covers an area of about 1 square kilometre. The scheme is envisaged to harness about 43,000 cubic meters of monsoon runoff currently going as waste, as well as to improve groundwater levels and sustainability of abstraction structures in the area. This is done through artificial recharge check dams. The Central Groundwater Board Bangalore has implemented direct rooftop rainwater harvesting for its office building located at Jayanagar, Bangalore. The rainwater from a rooftop area of 300 square meters is collected in the existing sump for immediate use. The rooftop area is kept clean and gratings are installed at the entry points of the downpipes to arrest the solid particles. A screen filter is installed before the storage point to remove the suspended solids present in the water. This arrangement can harvest about 240 cubic meters of rooftop rainwater annually. Improved techniques, such as the scientific monitoring mechanism, help in the selection of areas for implementing artificial recharge schemes, as well as for assessing the impact of these recharge schemes. The Central Groundwater Board set up digital water level recorders throughout the state. These recorders, or piezometers, facilitate the accurate recording of water levels at desired intervals. Monitoring stations are established by the Central Groundwater Board under the Hydrology Project. Network observation wells are also established all over the state for water level and quality monitoring. Regional water level and water quality maps prepared using the monitoring data help in better planning and management of the groundwater resources. If the present trend continues, the water crisis could precipitate faster than expected unless integrated land water use strategies are implemented. Promoting innovative water management techniques, including rainwater harvesting, artificial recharge schemes, and revival of traditional water conservation practices are absolutely essential. Community participation in the water management practices has to be encouraged. Increased efficiency of water-related activities has to be the watchword to overcome the present crisis. Water conservation awareness should go hand in hand with the implementation of the solution to stem this problem. Nature is giving us warning signals. Let us heed those signals before it is too late. Water is precious. Let us work to save every drop we can.